condensation of aldehydes and ketones with ammonia and its derivatives. So ammonia and its derivative. So we can write ammonia. So it is NH2. So I'm writing it as H, right? And if you consider its derivative, for example, NH2R. So NH3 and NH2R, where R is equal to, R is can be hydrogen, it can be NH2, it can be OH, or it can be NHCO, NH2, etc. Okay, and these are the derivatives of ammonia, we can say. So when these react with carbonyl compounds, what is happening? Let us see. So this is a carbonyl compound plus the ammonia derivative. I am writing H2NR. So ammonia you will get when R is equal to H. Okay, so here it is, the ammonia derivative. So when the condensation reaction happens, what is happening here? One water molecule will be eliminated. One water molecule will be eliminated. So that what you will get? You will get C double bond N R along with water. So this is the reaction. So according to the nature of R, the product obtained will change. So this is the overall reaction of condensation of aldehydes with ammonia and its derivatives. Now let us look into the mechanism of this reaction. Let us look into the mechanism. So we have the carbonyl compound C double bond O. We know that there is some delta positive here and delta negative here because of the electronegative nature of the oxygen. The pi electrons will be slightly shifting towards oxygen. So here there is slight deficiency of electrons. So a nucleophilic attack will take place in the carbon. So when you have an ammonia derivative, I am writing it as NH2R. So what is happening here? Ammonia is having one lone pair. It will attack the carbonyl carbon and this pi electrons will shift to oxygen. Oxygen is having two lone pairs already. So what will be your product? Your product will be C, then O minus. So now there are three lone pairs, right? And the two valencies, and here what has attached? Here we have N H2R. So one H, the second H and R. The next step is very important step, which is a reversible step. What is happening here? The next step is proton transfer. So here what has happened? Here it is a nucleophilic attack. So here it is nucleophilic attack. Now it is a proton transfer reaction that is going to happen. So proton transfer. So you have seen that the OH is O is negative here, right? So we have a hydrogen here and there is a charge on N. Is there any charge on N? Yes, there is a positive charge on N because N has given one pair of electrons. So here in order to neutralize this positive charge, what happens? An electron, when a proton will be abstracted by this oxygen, and oxygen also will get neutralized. So a proton abstraction will take place, and so it will be taking, then this will shift. Okay, so what it results? It results in a compound which is carbon is there, and now the carbon OH link is there. So here we have two electrons, the two valencies. We have now only one hydrogen and R, HR. Now the lone pair of nitrogen is also back. Okay, so this is a very this is a reversible reaction. The product is not stable. So what happens again? Protonation will happen. This reaction is taking place in presence of acid. Okay, so when this is taking place in presence of acid, so we have the acid in the medium, right? So what will happen? Oxygen again will take up one proton. Okay, so what will be the product? So here again protonation will takes place. So here it is protonation. So when protonation takes place, it is carbon, and now it is H and O is positive and only one pair of electrons, and N H R, right? So if you are getting intermediate compound like this, you should, or product like this, we have to imagine that next step is removal of water. Okay, so how water will be removed? There will be shifting of lone pairs and oxygen. So what will happen? So you will be getting a product. So how will be your product? Your product will be, now this side is not there, so we have carbon, 2 valencies, now it is double bond, and N and H and R. What's the charge on nitrogen now? Nitrogen is positive. So in order to neutralize the nitrogen, what should go? H plus should go. So what we have? We have B minus in the medium. So what will happen? B minus will take up H. This bond will shift. And what will be your product? C. Now double bond, N, H has gone. So what is there? R. Is this product similar to this? Yes. So your product is ready along with HB. So here minus H2O will also be there. So this is here also one deprotonation is taking place. Okay, so when deprotonation is taking place, here dehydration is taking place. So here what is happening? It is a removal of water. Okay, here it is again deprotonation. So this is the reaction mechanism for condensation of aldehydes and ketones with ammonia and its derivatives. So you can obtain many products according to what is your R. So if R is H, R is NH2, R is OH, NH, CO, NH2. Let us see one by one what are the products that can be obtained if you are having different sets of R. So I will show it to you with an example. So again I am continuing with the condensation reaction. So what we have C double bond of, this is our carbonyl compound. Now this carbonyl compound I'll write, let us consider NH2H. What is NH2H? That is your ammonia. Okay, so when ammonia you are using, so when you are using ammonia, what you will be getting? Same this you should keep in mind. This is when you are writing the reaction, this part you should keep in mind. This hydrogen should go and NH should be there. So it is C double, 2 bonds are there, then double bond will exist. Double bond will be there, is oxygen, and H2 will go over. Then what you will get? You will get NH along with H2. Okay, and this product, it is known as imine. So when it reacts with ammonia, you will get imine. Okay, and now the second reagent, let us consider NH2R. NH2R. What is this? This is a primary amine. This is a primary amine. So when it reacts with primary amine, again you should think about or remove this hydrogen. Here also you have removed this hydrogen. So what is remaining here? N and R. So you will be getting C double bond N R. This is similar to this compound, right? And here, if this is a primary amine, what you will be getting, so if H is not there, this is generally known as Schiff's base. So Schiff's base is an imine derivative. Okay, so this is known as Schiff's base. the Schiff's base. So along with that, what you will get? Water. Okay, water will be the product in all your reactions, byproduct. So now let us consider, let us remove R with OH. So again, here you have, here H2 will go and oxygen. So what will be your product? So you will be having C double bond NOH plus H2. So what is this? This is known as oxime. This is known as oxime. So when, and what is this? This is hydroxylamine. So when aldehyde undergo condensation reaction with hydroxylamine, it gives you oxime. Now let us consider another one more, which is, here I am going to replace R with CONH2. Let us see what is it. So it is, I am going to write NH2, now NHCONH2. Okay, so this is known as semi-carbazide. This is semi-carbazide. This is semi-carbazide. So when this undergo reaction with semi-carbazide, what will be the product here? Again, you have this hydrogen that has to be removed. So what you will get? C double bond N NH CONH2 CONH2 plus water. CONH2 plus water. So what is this compound known as? That is known as semicarbazone. Semicarbazone. Okay, and if you are using a hydroxyl, if you are using hydrazine, it will result in hydrazone, phenylhydrazine. The condensation with phenylhydrazine, phenylhydrazine is one of the test for what we will use for carbonyl compounds. Okay, this is semi-carbazone. So these are the products that we can obtain as per the changes happening with R. So for different derivatives, you will be getting different products. With ammonia imine, with primary amine, the derivative of imine or Schiff's base. With hydroxylamine, you will get oxime. With semi-carbazide, you will get semi-carbazone. Now let us see one example in which we are considering one compound, that is, let us consider acetone. Acetone is CH3 C double bond O CH3. When this is undergoing reaction with NH2H, what you will get? You will get C double bond. This oxygen will not be there, so here what will be there? CH3. Here also CH3NH. Okay, so this is an imine what you are getting. Then again I am using NH2R. So what product you will get? CH3 CH3 double bond NR. Again you are getting a Schiff's base. Now the next NH2OH. So again you have CH3 CH3. You will be getting double bond NOH. This is acetone oxide, acetoxime we can say. This again is a Schiff's base of acetone. Okay, then another one, we are using semi-carbazide. So what is the product obtained? NH2 NHCO NH2 we are using. So what will be the product? Double bond. So here it is CH3, here it will be CH3 double bond N, NH, Cu, NH2. So this is acetone semicarbazole. Okay, so depending upon the nature of the derivative used, we will be getting the respective products.